can just hang out. All right, 6th grade. Yeah, right. Our objective today is to start off with the second warm-up, which is up here. Okay. Can someone tell us the answer to number 1? Doug? Good. Who can explain why you don't move that? Why don't you switch it or move it, Alyssa? Yeah. I was glad you guys realized that you only move a negative or move it if it's the exponent's negative. We don't care about the coefficient. It's the exponent that we want to be positive. So your coefficient is allowed to be negative. Another thing I notice is don't forget there's a 1 here. Okay? If you don't see an exponent, it's a 1. Okay, Briar, number 2. Good job. X to the 5th over y to the 3rd. That's a 5. Okay, and then number 3, Matt. Awesome job. Okay, questions, Jeremy? Negative 2 to the 6th power over negative 2 to the 5th power? Well, technically that base is not the same. No. Nope. You're not going to see problems like that in Algebra 1 or pre-algebra. When you get to Algebra 2, you'll see more difficult problems like that. So don't worry about that right now. It's a very good question, though. Okay, Annalise? 12? Okay, when you multiply same base, add exponents. So all you need to do is rewrite the base, add the exponents. It's probably too easy. That's probably why it's confusing. Rewrite the base, add the exponents. Doug? You got y to the negative 10th? Okay, I'm not sure how you got that, but it should not be negative. So first, you want to move your negatives first. So order of operations of exponents. Get rid of parentheses first, then move negatives, then simplify. So your first step should be 2 to the 6th, x to the 10th, y to the negative 6th over 2 to the 2nd, x to the 2nd, y to the 4th. So, Doug, the next thing you needed to do was move the negative to the bottom. You got to move the negatives to make them positive. That's what you did wrong. Because when you move that to the bottom, you have y to the 4th, y to the 6th. When you add those, you get positive 10. So get rid of parentheses, then move negatives, then simplify. Matt? Well, go ahead. Yeah, and then you moved it to the bottom. Yeah, and to answer both your questions, it still works that way. The reason I don't tell you to do it that way is a lot of people make more mistakes. Like Doug, for example, if you would have left it like that negative, it's wrong. So to eliminate that or alleviate that, if you move the negatives first, that will not happen. Okay, but you can still do it as negative 6 minus 4, which is negative 10. Write it on the top like Matt said, then move it to the bottom. But be careful if you do it that way, okay? Okay, anyone else on this warm-up? Sean? Yeah. Are you sure? Okay, I'm trying to understand what you're saying. Okay, you sure? If you think about what you want to ask, please ask me. Okay. All right, let's go over the second warm-up. Okay, I'm just going to write these ones up here. This was page 60. It was 8-5, 1 to 12. So this was 8-5, it was page 60 in your homework packet. You guys just had 1 to 12. Now, some of these were a little bit harder, so I'm interested to see how you guys did. Okay, Zach, we're going to start with you on number 1. Good. Briar, number 2. Oh, yeah, sorry, I'm writing things wrong. Good job. Sean, number 3. Good job, that's perfect. Okay, go ahead.
How do you know if it's supposed to be on the top?
Okay, when you subtract numerator exponent minus a denominator exponent, it always goes on top.
Okay.
So the result of your subtraction problem always goes on top. When you subtract and if it's negative and it's on top, you then move it to the bottom.
Oh, okay.
Does that make sense?
Yeah, I see what that is.
I explained that yesterday, but until you actually do problems, that doesn't really make sense.
Okay.
Annalise?
Like Sean's question, what if you're combining 2 on the bottom or on the top, then it just stays on the bottom?
Unless it's negative. Okay, Annalise, number 4. Good. A to the 10th over B to the 15th. Number 5, Charles? Good. 3 to the 3rd. Number 6, Mary? Good. A to the 12th over B to the 8th. Adam, number 7? Oh, you scare me. Yes, 3 squared. That's okay. Over 2 squared. Number 8, Emma M? Yeah, that one's hard. You're close. That was a difficult problem. Jeremy, what did you get for 8 since you're the next person in line here?
2, 4, 5, 6, 7.
Good job. That's a tough one. Yeah, I know. You were close. Donatus, number 9. Good job. Okay, number 10, Alyssa. Say that again. Nope. Move negative exponents first, then simplify. Charles? Good. 7 to the 3rd. That one's tricky if you did not move the exponents first to make them positive. Emma H, number 11. Good. A squared, B to the 5th. Number 12, Doug. There's not an X in number 12. A's and B's. You didn't get to 12. Okay, Matt, did you get? I know you came in late. Matt? There we go. A to the 10th over B to the 30th. We want to make sure we have some A's and B's in there. Okay, there's all the answers. That was the warm-up from page 60. Mary? Okay, I'll go over that one. Okay, can I move this and then I'll answer the rest of your questions? Matt, okay. I'll come back to you guys. Everyone else that has their hands up. Okay, Mary, number 12. So let me just write down the next step. So after we distribute the 5 through, to get rid of parentheses, we have A to the 10th, B to the negative 20th, over B to the 10th. Okay, that's why then. Sean? Okay, does anyone else need 12? Okay, Sean, did you say yes, Emma? Okay. Sean, number 7, 2/3 all to the negative 2nd power. So the very first thing you want to do is put a 1 above the 2 and the 3. Distribute the negative 2 to each exponent. So you get 2 to the negative 2nd over 3 to the negative 2nd. So parentheses are gone. Second step in the order of operations of exponents is move the negatives. So you just switch them around. So it becomes 3 to the 2nd over 2 to the 2nd. You can't simplify any further because the bases are different. You got it? Okay. Annalise? Do not ever do that. It happens, but don't do that. Emma M? Sure. Actually, I don't know. Do you think I can, Emma? Okay, p to the negative third, q to the negative second, over q to the negative third, r to the fifth, all raised to the fourth power. Okay, first step. This one's just tricky because there's a lot of things in it and a lot of negatives. Distribute the 4 exponent to every single term. So we have p to the negative 12th, q to the negative 8th, over q to the negative 12th, r to the 20th. You with me? Okay. Move the negative exponents. These two get moved to the bottom. This one gets moved to the top. Okay, that's why. So q to the 12th over p to the 12th, q to the 8th, r to the 20th. And then your last step is subtract the q's. 12 minus 8 is 4. Talk about them like they're people, right? Sean? Yes. So when you subtract a numerator minus a denominator, it always goes on top. It always goes on top. Now, when you subtract and it goes on top, if it's negative, then you switch it to the bottom. Oh. Okay. We're doing more of these today to take care of all those little things you guys are so confused on. Emma? Yeah, you could think of it that way. If you don't want to follow my order of operation rules, you could think of it that way. Like I said, there's a lot of ways to do these. You guys are going to develop your own like little strategies and shortcuts for them. I'm fine with that. Matt? You put down 2? Oh, you mean instead of a z, you put a 2? No, I won't mark that wrong. Unless there's a 2 in the problem with the z, then you're in big trouble. Okay. Okay, anyone else on the warm-up before we go over homework? Okay, let's go over homework. I'm going to read some of these just for time today, because I want to have time for you guys to practice some. So 4.6, I'll wait till you guys have it out. Sean? Yeah, we're going to start with 4.6, and then I'm going to go to that, which I need to hold. Yep. I always like to go over all homework so that you guys can check your work. All right, I'm going to put the answers up for 1 through 10. I'm going to read them, okay? So stay with me here. Number 1 is C. Number 2 is 1 over 14 cubed. Number 3 is 1 over 9 to the 7th. Number 4 is 1 over 18 to the 5th. Number 5 is A. Number 6 is 24 over D. Number 7, am I going too fast? Number 7, M to the 4th over N to the 2nd. Number 8, 27 to the negative first power. 9, 81 to the negative first power. 10, 63 to the negative first power. 11, 5t to the negative fourth. 12, 6zy to the negative fifth. 13, 11p squared q to the negative sixth. 14, 22 to the fourth. 15, 1 to the eighth is the answer. 16, 1 over 12 to the 11th. 17, 3, it's right here. 3 over w to the fifth. 18, 45h to the eighth. 19, 84 over m to the 13th. Make sure, before I flip, just make sure you've checked 1 through 19. We'll come back to questions. Right here, it's right here, Doug. No. That's, yeah, but you can't say that the answer is negative 27. Negative 27 is completely different than 27 to the negative first power. In other words, negative 27 is not equal to 1 over 27. It's a huge difference. Don't do that, okay? Keep the negative above the exponent. Okay, I'll come back to questions, guys. Okay, number 20. I didn't have these ones filled in. Anyone want to tell us what they got for 20? Charles? Nope. You probably just subtracted or added wrong. Mary? Close. You changed something by accident. Matt? No. Close. Annalise? Just tell me what you have. Yes, he said that. That's not right. Alyssa? Yeah. 1 over 10 to the 8th. Alyssa, can you just tell us real quick how you got that? Yep. Good job. We're multiplying 10 times 10 to the negative 9th. So if you move 10 to the negative 9th to the bottom, it becomes positive. And then you do 1 minus 9, which is negative 8. And then you move it to the bottom again. And that's how you get 1 over 10 to the 8th. Mary, you accidentally multiplied the bases. Don't multiply the bases. You always rewrite the base. So that was your only mistake. Always keep the base the same. Do not multiply the bases. We're doing more of that today. Annalise? Okay. Because they told you that scientists have created a 10 nanometer transistor for use in computers. A nanometer is 10 to the negative 9th meter. So you need to find what the length of the transistor in meters is. So to find that, all you do is multiply them. The 10 times 10 to the negative 9th, all you're doing is multiplying them to find the length of them. So do you want me to explain how to multiply them, or are you okay with that? Yep. And then subtract exponents. You okay with that? Right? You got to keep simplifying. Just like we've been doing. So then this is a 1, subtract, you get 10 to the negative 8th, and then move it to the bottom. Okay, Donatus? Yeah, I have that as my answer too. Yep. Okay, number 21, Briar, what'd you get? Good job. 10 to the negative 7. 22, Emma H., what'd you get? Good. How did you do that one? Okay. Do you remember how you did it, or you just kind of you just did mental math? Okay. Charles, how'd you do 22? Good. And then you got 6. Good. Mary? $10 million to the negative 4ths? Yeah. Yeah, I'm okay with that. It does say a power of 10, but yeah. On a homework assignment, I'm okay with that, but just read carefully if it's a test, because of how specific they want that answer. Annalise? 21, we're going to actually do this with scientific notation. So if you were confused on 21, don't worry about that. I will give you a much easier strategy to use on Monday when we talk about scientific notation. 20 and 22 are just basic word problems. You just need to... Okay, so anyways, 21 is more scientific notation. You guys can do it with guess and check, or just if you remember scientific notation, but again, I will get to that on Monday. Okay, Alyssa? Okay, because if you take, so it says a milligram is 10 to the negative 3rds gram. Kilogram is 10 to the 3rd grams. How many times the mass of the milligram is the mass of a kilogram? Which sounds very confusing. You need to divide these to figure out how many times more the milligram is than the kilogram. So if you divide these, this one's negative, so you have to move it to the top and then just multiply them. So you'd have, 10 to the 3rd times 10 to the 3rd. When you multiply same base, add the exponents. and you get 10 to the 6th. That's a very confusing problem because, gotcha. That would be why. Okay, 23, 9 over 4a to the 29th. 24, 15u over 17. 25, 19 over k to the 26th. Whoa, did I just read that? 26, 14r to the 11th. 27, c over d to the 5th. 28, y to the 7th over w to the 8th. That's all you guys had to do. These ones are up there, but you don't need them. Because I had this from last year, and I always assign different things. That's why. It's not that I forgot. Last year, they didn't do those ones. Some things I still have from last year, and some things I don't. Annalise. You forgot to subtract. When you have u to the 16th over u to the 15th, Annalise, you're dividing same base. You need to subtract exponents. 16 minus 15 is 1. Yep. Okay, Matt. Okay, hold on. Okay, when you subtracted, what's 3 minus 11? Yep. And then you move it to the bottom. You just subtracted wrong. Anyone else? Annalise? Yeah. Okay, pick one for now. Okay, 18. Okay, 18, we have 9h to the negative second times 5h to the 10th. So step one, I would multiply these together. So we get 45, h to the negative second, h to the 10th. Okay, tell me why you did that. Why'd you move the 9? The 9's really to the first power. Only move this term because it has a negative exponent. Okay, only move. That's probably why you missed that section, some of them. Only move the term that has a negative exponent. That doesn't matter. You can either multiply first or second. I didn't give you an order of when to multiply or when to simplify. That's up to you. I always multiply first and then move the negative exponents. Yep. And you get 45 h to the 10th over h to the second. And then all you're doing is subtracting exponents. (45h to the 10th over h to the second). And then you do 10 minus 2, which is 8, which goes on top. When you subtract, it always goes on top. Mary. Yeah, we're getting to that. I know you told me that. We're going to do some more problems with that. Emma? Yep. Okay, 17. We have 3w to the negative 9th times w to the 4th. So all you do on this one is move the negative exponent to the bottom. So we have 3w to the 4th over w to the 9th. And then, you with me? Subtract exponents. So 4 minus 9 is negative 5. And then this goes to the bottom. Got it? Okay. Doug. Sean? It's up there. So like after you get rid of parentheses, which is step 1, step 2, move negative exponents. Step 3 is simplify, but there could be a lot of simplifying that needs done. Oh yeah. Simplify again. Yes. You keep simplifying until all the negatives are gone and until all the bases have been simplified. Okay? Doug. Yes. Okay, 19. we have 14m to the negative 4th times 6m to the negative 9th. So I'm going to multiply these together first, Doug. 14 times 6 is 84. I'm going to rewrite the m's. Then you need to move the negative exponents to the bottom, which is both of them. So we have 84 over m to the 4th, m to the 9th. And then one more step, add exponents. Got it? Okay. Matt. 9 over 4a to the 29th. All right. One more question, Emma, then we're moving on. Can I do 23? Let me see what that problem is. Yeah. 23, we have 18, a to the negative 20th over 8a to the 9th. So first step, simplify your fraction. Okay, that becomes 9/4. And then move a to the negative 20th to the bottom. So we have a to the 9th over a to the 20th. After you move it to the bottom, just add exponents. So 9 over 4a to the 29th. Okay. Sean, go ahead. Last one for real this time. Yep, we just did that one. Yep. Annalise? Yeah, here, they're up here. I just did 19 twice. Go ahead. Okay, what's a times 1 for number 5? It's a times b to the 0. So b to the 0 is 1, a times 1 is a. Okay, and the answers are up there for the other ones. Correct, but that's not the, yeah, but that's not the case in this problem, but you're right. If the whole thing was to the 0 power, then it would be 1. Annalise, go ahead. Okay. All right, guys, I need you to open up your homework packets, page 59, and you also need your notebook or a piece of paper out. Oh, did I not go over, wait, I forgot about, I knew it. I knew I'd forget about that. Sorry. Sorry, I forgot about page 60 homework. Sorry. I knew I'd forget about that. Okay, page 60 homework. You guys had 1 to 15. So let's go over these. I'm going to read them. Number 1 is 4 to the 3rd, a to the 15th. Number 2, 1 over 2 to the 12th. Number 3, m to the 12th over n to the 16th. Number 4, x to the 10th. Number 5, 2 to the 13th. Number 6, 2 to the 2nd, 4 to the 3rd, x to the 14th, y to the 6th. You guys okay? 7, x to the 16th. 8, x to the 17th, y to the 19th. 9, 5 to the 4th. 10, 1 over a to the 7th. 11, 3 to the 3rd, f to the 10th, over g to the 7th. 12, x to the 18th. 13, 1 over d to the 8th. 14, a to the 6th, b to the 12th. 15, x to the 8th, y to the 4th. Okay, now that my arm hurts from all that. Alyssa. Nope. The order, yeah, technically the numbers should be first, and you usually keep the variables in alphabetical order, but it does not matter. I will not mark something wrong if you don't have it in a certain order. Not for pre-algebra, at least. Mary? You got it? Charles? Sure. Annalise, are you asking about 6 too? Okay. Number 6, we have, let me write the problem down here first. All right, step 1. Put a 1 above anything that does not have an exponent. Okay? Distribute the exponents to everything. So we have 4 to the 3rd, x to the 12th. Doug, you with me? Second set of parentheses, the 2 goes to everything. So 2 to the 2nd, x to the 2nd, y to the 6th. And then the last step, you can combine the x's. So we have 4 to the third, 2 to the second, x to the 14th, y to the 6th. The order does not matter. Charles, what'd you do wrong? Oh. You changed 2 to the second and made it 4 and made this 4 to the 4th. That's actually better. You're good. I just didn't make my answer like that because I did not do any problems with you guys like that, but that's actually more simplified. So I'll accept either answer. Sean? Mm-hmm. Only if you change 2 to the second to 4. If you change 2 squared, you got to think about that. No, okay. If you leave it like this guy up here, the bases are different. So if they're different, you cannot combine them. However, if you change 2 to the second to 4, then 4 to the third times 4 is 4 to the 4th. You don't have to do that. This answer's fine. I was just answering Charles' question. Annalise? Not if they have exponents. Remember I answered this with your warm-up? The only time you can multiply is if it's like 2 times 3. If, Annalise, it's 2 to the 4th times 3 to the 8th, you can't combine those because the bases are different. It'd be 6y squared. Okay. Mary? Who can answer that? How do we know when to add exponents? Yep. When you're multiplying as the same base, add them. You multiply exponents when it's something like this, a power of a power. So if it's an exponent raised to other exponents, that's when you multiply. We're gonna do more practice with that. I'm hoping soon. Emma? Here. Charles, is that a hand? Yeah, that'd be y to the 18th. That's a power of a power rule. Y to the third to the 6th is y to the 18th. Y to 3 to the 6th, like that? Well, you'd have to have parentheses, first of all, like that. It'd be y to the 18th.
I thought when you do 3 to the 6th, y to 3 to the 6th.
It'd be y to the third to the 6th is how you say it. You won't have a problem like that. Like this? You won't have a problem like that. You won't. Hi, how are you? So, but good question, but you won't have a problem like that. Briar? Okay, so 3 different parentheses now? So like this, x to the third, to the second, to the 4th. That still uses power of a power rule. So you would still, good question, 3 times 2 times 4, you would still multiply all those. You guys are making these way too hard. We're not there yet. Emma M. I can do number 11. Okay, number 11 is definitely tricky. All right, 11, let me write this thing. This thing is huge. 3f to the 4th, g to the negative 3rd, all to the 3rd, f to the 2nd, g to the negative 2nd, all to the negative 1st. All right, you guys ready for this one? Okay, first thing from yesterday we talked about, there's parentheses. The very first thing we do is distribute, okay? Emma, what's really to this 3? What power? Good, there's really a 1 here. So this gets distributed to every exponent. So here's what Mary was asking. That's when you multiply, okay? So 3 to the 3rd, f to the 12th, g to the negative 9th, okay? Second one, you don't have to put a 1 on anything. We're distributing the negative 1 to each exponent. So we have f to the negative 2nd, g to the positive 2nd. You with me? So that was step 1 in our order of operations of exponents. Emma, what should we do next? Good, so put a 1 underneath everything, circle any of the powers that have a negative exponent, this one and this one. They get shifted to the bottom, so you're moving or switching them, however you want to say it. So now we have 3 to the third, f to the 12th, g to the 2nd, all over g to the 9th, f to the 2nd. Are we done? No? What else can we do? Anyone can tell us. What else can we do? Matt? Yep, so subtract the f to the 12th over f to the 2nd, and subtract the g to the 9th and g to the 2nd. Now here's where it gets tricky, because when you're subtracting, one of them is going to be positive and one of them is going to be negative. So we have 3 to the third. Emma, what's 12 minus 2? Good. And then, Emma, what's 2 minus 9? Good. Are we done? Nope. What do we have to do? We're never going to be done. We're going to be here forever. So put this on the bottom. Move the negative to the bottom. This is never ending. So we have 3 to the third, f to the 10th, over g to the 7th, which is what we have on the board as the answer. Okay. I will warn you guys, yeah, you'll see problems like this on your test next week. But if you follow, get rid of parentheses first. Second step, move negative exponents. Third step, keep simplifying until you don't have negative exponents. Then you're good. You'll get it. Okay, Alyssa? Yeah, it'll be the middle or end. I'll let you know for sure tomorrow. Yeah, I'm guessing more of the Thursday, Friday range. I'll let you know for sure tomorrow. Doug? Okay, good. Okay. Up here? Yep. You do the 2 minus 9. Okay, so you do 9 minus 2 and you leave it on the bottom? That's fine. That's what, who told me that? Emma, is that what you told me? That's what your dad told you last night. That's another little trick that you guys I know will learn. You can do it that way. Annalise? Okay, so hold on. So let's say we have 2 to the 4th times 2 to the 4th. Is that what you mean? The bases have the same exponent. Okay, 4 to the 3rd times 5 to the 3rd. Okay, what do you guys think? Okay. Shh. Okay, I know you're so excited to answer these. Matt, you can't. Good. You cannot do it, guys, right? The bases are different. So you cannot go any further. We don't care if the exponents are the same. The bases have to be the same. Mary? No. You cannot multiply these because this is not 4 times 5. It's 4 to the 3rd times 5 to the 3rd. Then you could multiply them. However, good job, Adam. However, Adam gave us the answer. The answers have to be in exponential form. Okay, do not multiply them out. On any state exam, on any standardized test, they're going to tell you keep your answer in exponential form. That's why I'm trying to teach you to keep them as exponents. That's how any standardized test is. They don't want you to multiply them out. I know in elementary school you guys are used to doing that. Do not do that. Okay? Doug, go ahead. Last question. Nope, that's what Mary just asked. No, bases are different. All you would do is move those to the bottom. It'd be 1 over 13 to the 6th and 5 to the 9th. Okay, let's hold off on those questions for later, okay? I need you guys to flip your homework packet to page 59. So homework packet to page 59. This worksheet is a really good practice worksheet for all types of exponent problems. So on page 59, there's 16 problems, okay? So all I want you to do are those 16 problems. This is a really good worksheet for me to collect and grade, hint, hint, okay? You should be able to fit it on here. If you think you need a notebook or another sheet of paper, that's fine with me, okay? This uses all the rules, okay? So who can remind us, when you multiply same base, what do we do with exponents? Sean? Good. What do you do with the base? Good. Keep the base the same, add the exponents. Okay, if you divide the same base, Briar, what do we do with exponents? Yep. What do you do with the exponents? Good. What do you do with the base? Good. Leave the base alone, subtract the exponents. Okay, anything to the 0 power, Donatus, is what? Good, is 1. Alyssa, what do we do with negative exponents? Move them to the other side. Good. Switch them or move them to the other side. We don't like them. You cannot leave your answer as a negative exponent. What do we do if there's an exponent raised to an exponent? Exponent raised to an exponent. Jeremy?
If there was an exponent inside parentheses,
Yep.
you would take the one exponent and multiply each variable with it.
Very good job. So multiply them together. Over the past 3 days, those are all the rules that we have learned. So you now are ready to do all different types of mixed up problems. So again, your assignment on page 59 of your packet, you can do on there if you want. If not, use your notebook. I may collect and grade this tomorrow. Just a preview for tomorrow. These are the problems we're going to do tomorrow. So come very excited. I know. Yep, on a Friday, we're doing some challenge problems, okay? Okay, Mary, go ahead. Shh, 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 shh. Okay. Good. Yeah, you're going to see that tomorrow. Doug. Good. Okay. I'll come back to see you because we got to get packed up. Okay? All right, guys, go ahead and get packed up.